Hi everyone, it's Neil Selvage here and thanks for joining me. I thought I'd put together this top 10 of installation slips, trips and fails, things that regularly crop up and areas that often need a little bit more attention when we're doing either assessments or on-site practical work, but also valuable to other occupations associated with our work, for the designers and also for the verifiers. So I thought I'd put these top 10s together and hopefully it's useful and certainly welcome any comments. So one of the big things that crops up initially is about the risk assessments and method statements. Are they being adhered to? Are they thorough enough and appropriate to the job and the task? Have all aspects been covered? Now, when I'm doing assessments, I often ask this question to the learner. I might dip into units of the risk assessment or the method statement to seek clarification that the learner knows what's there and what's expected and whether they're compliant to that. So all quite critical elements, and certainly looking at your method statements, risk assessments prior to attending site can certainly ease a lot of problems later on. The next one is meeting our site personnel, site managers, QSs, engineers, architects on site. Often I hear the common phrase that the gas protection isn't really required here, or it's over specified. You know, there isn't any ground gas. I don't know why we're doing it. The next door site never had to do it. So, you know, that understanding and knowledge is quite a barrier to certainly the installers being the coal face of doing the work. So it's a problem we have to overcome a lot, and trying to educate and share information with people that are less knowledgeable or not encountered our working environments can be quite a challenge. But as you can see in the clip running behind me, I've got a real diligent site manager, and he was really keen to take on and understand what was required and what was needed, because he knew that the local authority were quite rigorous with their planning conditions. So it's quite rewarding when that happens, but it can be quite challenging when it doesn't happen and you hit that barrier with a site personnel. Design. It's always a funny area. Who is the designer? Who's going to take responsibility? Who's going to put that line on a piece of paper? Where's that line going to go? And I often look at different drawings, designs, details, and ask the person that's done it, you know, do you understand the complexities of, you know, the line you've drawn has taken you quite very quickly. You've drawn it and put the location, but what happens when it turns around 90 degrees? What happens when there's a change in level? So some of those specialist and more complex areas will be most probably taken on by the installers quite naturally. They do it all the time anyway, but not really understood and appreciated by the designer. Likewise, how sequencing of work happens. So for example, with shuttering, is it going to sit on the inside, or are you going to line to the inside, or how is that sequence going to work? And I was just doodling around earlier with a pen, and often this scenario crops up when we're on site, that we do quick sketches and try and formulate what is the best route to take. But also getting all the components of the gas protection in. Okay, the structural slab is going to be kind of taken care of, hopefully by the structural engineer and the geotechnical engineers who understand what the slab needs to do in regard to holding up the building in the environment that it's in, but also incorporating all our components, such as the ventilation layers, or, you know, the medium that's going to allow gases to migrate out of the building, and likewise implementing the gas protection to go into the system as well. So all difficult little bits and pieces that we have to cover. But we also need to look at the design in the form of how do we get the products to work with more scope. Here we can see a laser screed operation or a flood pour going on, but there's been no thought process with regard to getting that concrete onto the slab. So you can quite clearly see the membranes being driven over. The designer would have had all good intentions of compliance with British Standard 8485 for appointing the appropriate membranes, and table 7 in British Standard 8485 refers to that. But it's worth, you know, speaking to the designer and saying, well, or speaking certainly to your line managers to say, you know, is this really right? Should we be doing this? That membrane will never withstand the loads and the pressures, and it goes against what the table 7 states in there about being suitably suitable to withstand the stresses and strains of the installation. So a little bit worrying, that one there. So elements that we need to look at. Also, we come across timber frame structures and sequencing how work might be done. Now, often it's all too good an offer when the ground worker or the bricklayer or other trades will offer to put the gas protection in, and it can often ease the program, i.e. you haven't got to bring a specialist in maybe twice. It fits in with the program much easier. And sometimes this can have an adverse effect on it where it's not really done properly. And these few slides here, we can see, timber frame structures. In this particular instance, there's been no real consideration, and I'm sure the designer of the system never incorporated the membranes to lap in such a formation that there's like there's a 9-inch void between the two. But understanding that, again, it falls to our designers to maybe make their designs more robust in specifying who does the work. Likewise, using tape systems and joining membranes. Here we've got examples where tapes have been applied by a non-specialist workforce, and it can be quite a difficult task, especially in wet conditions, in cold conditions. As we can see on these couple of slides here that are cropping up, we can see perimeters, and from a distance they look fairly reasonable, but closer inspection we can clearly see that certain corner details have just been overlooked and not treated as gas protection, but simply as a DPC, a damp proof course in the building. So elements like that really need to be factored in and followed through during the course. But also, I'm going to talk later about the verification. It's a critical part that's got to take place as well. Heat fusing the membranes. Well, this is often used by the more specialist installers. They will tend to have the heat guns as their main tool of choice. And here we've got an example of a technician welding up some membranes. Very effective, quite a productive way of doing it, provided the membranes are clean. Again, it's critical that we see that cleaning take place, and the management of how you keep the edges clean and ultimately keeping the whole project clean. But I often encounter learners that might be using the heat guns with either the wrong temperature setting. So I'm going to pop up a pizza here. You can I put the pizza up here as an example, and we've got the cooking instructions here, and we can clearly see the time is 10 to 12 minutes and it's got a temperature there. Well, this is an American cooking instruction, but you can see the temperature set and the time is set. So that really relates to us with the temperature that we're going to weld at and the speed that we're going to weld at. So when I see technicians operating the temperatures way too high, is it like cooking your pizza? If you want it in, say, 6 minutes or 7 minutes, do you just turn the heat up higher and hopefully it cooks in double the time or half the time? So those factors need to be considered when hand welding and working with different products as well. Some products are going to be more tolerant to heat, others not so. Then we move on to machine work. Now, machine welding, again, is a brilliant method. It's very fast, very efficient. But again, understanding the parameters that are required. So we take the combination here of looking at the heat setting, the speed of the rollers, so very similar to what we were doing with the hand welding, but also we need to look at the pressure that we're going to apply to the membrane. And this is really reliant on understanding the thickness, the specification of the membrane, because often I see technicians overstressing or overpressurizing on the seams. So, by putting too much pressure on that, we'll actually cut through the membranes, where the opposite of that would be not enough pressure, not allowing the heat to actually bond correctly. So, taking the machine out of the box and just using it as it isn't really the appropriate method. So as we come to the final stages, we're going to look at the verification side of things. And again, it's very important. It's part of the design. The designer should be incorporating the verification that all the components are suitable, they're fit for purpose, and they are going to be checked and confirmed that they are so. And here we've just got a few examples. Well, first of all, I'm looking at the RAMs, because us as installers will be looking at the risk assessment and method statement to see how that complies. But we can see a technician here on site carrying out verification work, doing the checks, looking for the holes. And ultimately, we the reporting of that is a key element as well, because this is going to have to be passed on to the client or other parties, or ultimately the planning authorities to sign this off. And you know, it's part of a planning condition. It's serious stuff. If this doesn't get done, it can actually you know, stop the whole building from being occupied or sold. Yeah. So lastly, I'm going to talk about the NVQ and training requirements. If you do encounter, or certainly for verification personnel, if you do encounter problems and issues, quoting that you need to go and get an NVQ, yeah, well, it would be nice, but often we find the learner or the person doing the install will be either reluctant to do so because they would say that they've got experience and they've got away with doing membranes previously, but also there'd be a reluctance to say, well, I don't really need the NVQ, I'm not going to do this work anymore. But we should be saying to the learner, you need to seek training rather than the NVQ. And it's a bit like, you know, sending somebody into their driving test when they've not had any lessons. I think they stand a pretty good chance of failing at that point. So hence, when people come to me requesting NVQ straight away, I go through a checking process. And if they can't fulfill those answers, then we will refer them to training. And we can see here we've got a group of learners picking up hand tools in a safe environment, learning the basics. So guys, that's what I'm here for. Here's all my details. Hopefully, if you need any assistance on that, please come and find me. I really appreciate you all coming in. Please comment and get in touch if there's any more questions. But hopefully these 10 pitfalls will help you all in what you're doing, whether you be a NVQ learner, whether you be a verifier, and even designers thinking about some of their elements. But thanks for joining us. That was 10 slips, trips and fails in about just over 10 minutes. Thanks, guys.